Our learning goal in this video is to graph a quadratic equation from vertex form. If you recall, in a previous video, we graphed a quadratic equation using the x-intercepts, the y-intercept, and then finding the vertex from the two x-intercepts, and then drawing the axis of symmetry, and then drawing the parabola. That method of graphing was useful when the quadratic equation was in factored form. If the quadratic equation is in vertex form, it will be easier to use the method that we're going to discuss in this video. And if the quadratic equation is in standard form, you can either change it to factored form or put it into vertex form and then choose your favorite method of graphing. Just a couple key points to remember before we do the example. The y-coordinate of the vertex is also known as the minimum or maximum value of the function. And also the maximum value of a function is the y value of the vertex if the parabola opens down. So your a value is negative, less than 0. The minimum value of a function is the y value of the vertex if the parabola opens up. So when a is positive, which means it's greater than 0. The steps that we will use to graph a parabola is step 1, complete the square to find the vertex. Step 2, plot the vertex. Then we will look at the a value and it will tell us the direction of the opening as well as the step pattern. If a is positive, the parabola opens up and has a minimum. If a is negative, the parabola opens up and has a maximum. And step 4, we are going to use the step pattern to graph the other points on the parabola. You may recall that the basic step pattern when the a value is 1 is 1, 3, 5, 7, and so on. So the example that we will look at is graphing y equals negative a half x squared plus 4x minus 3 by first completing the square. We talked about the steps for completing the square in the previous video, so we will apply those here. The first step is to take out a common factor, if necessary, from the first two terms. It is necessary here because there is an a value of negative a half, so we will do that. So we get y equals negative a half bracket x squared minus 8x minus 3. Take a minute to make sure you understand why this value is negative 8 and not negative 2. What you need to do is think of how many halves go into 4. So half goes into 1 twice, so half goes into 4 8 times. And if you were to expand this back, you would get negative a half x squared. Negative a half times negative 8 is positive 4, which is what you want from up here. So you will see these questions when you're factoring out a half. Just be careful that you're not dividing by 2, that you're actually dividing by a half. Step 2 is to take the coefficient in front of the x, which is negative 8, and divide it by 2. So I will write negative 8 divided by 2, all in brackets, squared. Negative 8 divided by 2 is negative 4 squared to get 16. So my equation becomes y equals negative a half bracket x squared minus 8x, and then I'm going to add the 16 and subtract the 16, end bracket minus 3. So my next step is to remove the minus 16, but remember you have this a value of negative a half. So I'm going to multiply those two together and then move that term outside of the brackets. So I get y equals negative a half bracket x squared minus 8x plus 16. I remove that negative 16 times by negative a half, which is positive 8, outside of the bracket. And remember, I already had that minus 3 outside of the bracket. So my next step is to factor this trinomial. So I want two numbers that add to negative 8 and multiply to 16, and simplify outside of the brackets by collecting like terms. So the two numbers that I want when I'm factoring are negative 4 and negative 4. And again, we already have that written on our page. That's when we took the negative 8 divided by 2, we have negative 4. So when I factor the trinomial, I get x minus 4, and I'm just going to write that in proper form. So y equals negative a half x minus 4 squared plus 5. So that means my vertex is 4, 5. And I know that my graph is going to open down because it has a value of -1/2. So now I'm going to graph this function by first plotting my vertex at 4, 5. So there's my vertex. And then I'm going to use the step pattern to find the other points. So again, the step pattern is we start off with 1, 3, 5, 7, and we multiply our a value to each of those numbers. You could do 9 times -1/2 as well. You could keep going to find more points, but 4 should be sufficient because that's 4 on either side of my vertex. And so 1 times -1/2 is -1/2. It might be easier to plot if you think of this as a decimal, so -0.5. 3 times -1/2 is -3/2, which is -1.5. 5 times -1/2 is -5/2, which is -2.5. And 7 times -1/2 is -7/2, which is -3.5. So the step pattern that we are going to use for this function with an a value of -1/2 is -0.5, -1.5, -2.5, and -3.5. So we will now apply that on the graph. So I go back to my vertex, and I'm going to go to the right by 1. And now I'm going to go down 0.5. So I have another point about here. My graph is not going to be that accurate because using a stylus is not very useful for graphing. I'm also going to go 1 to the left and down 1/2. And now I will apply the next step from these 2 points. So I'm going to go 1 to the right and then down 1.5 to get a point around here, or at that point. And then I'm going to take this point, go 1 to the left, and go down 1.5 to get that 5th point. So far those are what my 5 points should look like. And then again, I'm going to apply the next step. From this point, I'm going to go over to the right one, and now I'm going to go down 2.5. So I will get a point here, and I'll go from this point, go to the left one, and then go down 2.5. And finally, I will apply the last step. So from our new points, I'm going to go 1 to the right, and then down 3.5. So that's half. 1, 2, 3. So I'm going to have a point here, and then from this point, I'm going to go 1 to the left and go down 3.5. So here. So using paper and pencil, just make sure your points are in accurate spots. And now we can clearly see this parabola. So I'm going to draw a nice smooth curve that goes through all of the points and draw an arrow at the end. And for full communication marks, I am going to label this graph.